Welcome to GMN tutorials once again. Please remember to subscribe and also to share this video so that other people can get the same knowledge and excellence which is being offered by GMN tutorials. Without further delay, let's go into our program for today. Our program for today is mostly based on GCE SCIENCE paper 1, section C, first question, based on velocity time graph. Based on velocity time graph. The first question reads, figure C1.1 shows a velocity time graph of a car of mass 1200 kg. 1200 kg. This is our velocity time graph. As you can see, this is the time of elapse, and this is the increase in velocity. Now, from here to there, this is what's called a constant acceleration. Constant acceleration. Let's analyze this diagram before we begin answering. From 0 here, as the velocity is increasing, any change with respect to time, as velocity increases with respect to time, this one produces what's called acceleration. So this is what's called this straight line shows a constant acceleration. Now here the acceleration becomes 0 because there was no change in what? Velocity. Should I say the change in velocity is 0. There is no change in speed. So since the speed is constant, the velocity is z equal to the acceleration tends to be 0. Then here it begins to decelerate. To decelerate, it's more like retarding. Hence, this is what's called constant retardation or constant acceleration. So here it's constant acceleration. Here it's constant speed. Constant velocity, sorry, because we are dealing with the velocity time graph with respect to velocity. This is constant retardation. Constant retardation or deceleration. So our first question says, calculate the acceleration of a car in the first 2 seconds. We know the rate change. So the change in velocity was with respect to 2 seconds. From 0 to 30 meters per second in the time of 2 seconds. So we are going to apply the formula for acceleration. Acceleration is equal to velocity, final velocity minus initial velocity divided by time. So from there, final velocity is 30. Initial velocity, where it started from, it is 0. Divided by the rate change in time is 2. So our answer here, we're going to have 15 meters per second squared. This is our required acceleration. No need to struggle. Yes. Question B. Explain why the acceleration between 2 seconds and explain why the acceleration is 0 meters per second squared. Explain why the acceleration is 0 meters per second squared between 2 seconds and 4 seconds. The reason is very simple, because the change in velocity is 0, meaning that it is just traveling at the same speed. There is no change in velocity because we define acceleration to be the rate change in velocity with respect to time. So any change in velocity with respect to time, that's what's called the acceleration. See, our C here is like calculate the displacement of a car while its velocity was increasing. The only time when the velocity was increasing, it's in the first 2 seconds. Because as you can see, from 0 changes from 10 with respect to time, changes from 10 all the way to 30. And from there, it was not increasing. So it has increased from 0 to 30 with respect to 2 seconds. So this is the required distance. This is the required displacement during which the velocity is what? Increasing indeed from 0 to 30 in the time of 2 seconds. So we're going to use the shape here. Whenever you want to find the displacement or the distance moved by a car or an object, based on the velocity time graph, we take the shape portrayed with respect to the motion of a car. So from there, we're going to say area, this is the area of a triangle. Area of a triangle is equal to half BH. Our base here is 2. So we're going to replace out of 2 multiplied by, our base is 2. Our height is this. Our height is just 30. When you multiply throughout, this 2 and 2 will cancel out. So it will be 30 meters. You doing this, you are good to go. You are good to go. That is 2 marks is for free. This 2 marks is for free. Then from there, calculate the resultant force on this car during its acceleration. So we have been requested to calculate the velocity, the resultant force when its velocity is increasing, in other words. So because this is the only time the acceleration is being produced. So we're going to use formula D is equal to force is equal to ma according to the second law of motion. So we're going to say the mass of an object, which is this 1200 kg, times what's the acceleration, which is 15 meters per second squared, which is being produced here. As you can see, this is the mass of a car, then this is the acceleration which we calculated in the first place. So plug in the values, we are going to calculate in this way. So we're going to say 1200 multiplied by 15, which is 18,000. This is 18,000 newtons. This is our required force. If they said the required force to before the car came to rest, we would have find this acceleration, which is the negative acceleration. Have you seen this? The negative acceleration, because the brakes are being applied in order for a car to stop moving, in order to come to rest from where it started, which is 0 in this case. If they were to ask such a question, so all we need is to calculate the acceleration here, which is the negative acceleration, then you multiply by with the same mass. You're good to go by applying if they need the amount of force required by applying the brakes. Yes. Last question. Distinguish between speed and velocity. One difference between speed and velocity is that velocity is a vector quantity. So velocity is a vector quantity, while speed is the scalar quantity. By vector quantity, which means that it has got both the magnitude and the direction. Then for scalar quantity, it is only have the magnitude, no direction. That's what we can say. Our last question, which is F, saying calculate the displacement of the car for the whole journey. For us to calculate the displacement for the whole journey, meaning that from where it started up to where it ended. So the motion started from 0 and ended after 8 seconds. So we need to take the area under the curve. So to simplify things, instead of taking down this area, and also this area, we need just to take this one as our trapezium or trapezoid. So our area for trapezium, we say area is equal to half A plus B H. Please, our A here in this case, the area of a trapezium, when the trapezium has been given in this form, that's the way it is. This shortest distance is what's called our A. Then from where it started up to where it will be ending, this distance is what is called our B. When you plug it, when the values which must be plugged here. So it must be from 0 to where it ended. A is our shortest distance, I repeat. Then B is our longest distance from where it started up to where it ended. So basically just A, from where it started moving with a constant velocity, that is our A. Then our height, it is with respect to velocity. So coming to our diagram here, this is our height. This distance from there to here is our A. Then from 0 to 8, that is what our B should be. Now we plug in the values. So our A will be 4 minus 2, show the difference, which is here, the distance. 4 minus 2, which is 2. So we plug in, say 1 over 2 is equal to 2 plus, what's the value for B? It's 8. Since it's coming from 0, then it's stopping from 8, or after 8 seconds, times our height, which is with respect to velocity. Here, this is our height, which is 30. Adding this, we are going to get 10 multiplied by 30, or we divide by 2. When we divide by 2 here, we're going to say 2 there, 1. 2 there into 2 into 10, it's 5. 5 times this, which is 150 meters. And by doing so, you are good to go. This is the required displacement from the whole journey. Please, we have come to an end for this question. Remember to subscribe and also to share this video to your fellow colleagues so that they can get access, you can get and access the same knowledge which is being offered by GMN tutorials. Thank you for your time.